Hello everyone, today we'll be talking about networking devices and we'll discuss concepts such as what are routers, what are switches, what are access points, and what are hubs, and how we use them in our small home office networks and how we use them in our corporate environments. So let's get started. So what is a router? A router is a layer 3 device that is used to route traffic, hence the name router. Routers forward packets by using something called routing algorithms and routing tables. Routing algorithms could consist of protocols such as OSPF, EIGRP, and RIP, but these routing protocols will be discussed in a later video since it's over scope from this video. But just know that they are used to determine the best next hop to get to your destination. Routers also create their own collision domains and broadcast domains on each interface that you connect to. A collision domain is a network segment where data packets can collide with each other when being sent on the network at the same time. In simpler terms, it's like a single lane road where only one car can pass at a time. If two cars or data packets try to go through at the same time, they collide, also known as a car crash. This collision means the data must be reset, slowing down the network, and with our car analogy, this means that the road is now blocked, basically, slowing down all the traffic. So this is why collisions are very bad, and it's very good that routers create their own collision domains. A broadcast domain is all the devices in a network segment that can reach each other with a broadcast message without having to go through a router. In simpler terms, it's like being in a big open room where if someone yells, or in other words sends a broadcast message, everyone in the room can hear it without the message needing to go through the door, or in other words, the router. So, and if a broadcast domain is not controlled and you have a very large network, this could cause a lot of slowdowns and a lot of congestion very quickly. And finally, routers are used to connect disparate or separate networks together. This is a device that allows you to access networks such as the internet. This YouTube video example that you're connecting to is possible because of your router. So in this example, let's say you're at home and this is your home network. You have a switch, you have some computers, and you have a laptop. You are connected to a router to connect to the internet because the router allows you to connect to greater networks beyond your local area network where your home resides in. This is how you can view videos on the internet, such as the video you are watching right now, because you are fetching this data from YouTube servers which go back to you, and this is possible because of routers and routing protocols such as OSPF and BGP, which is a routing protocol that's used on the internet. Here's an example of a router in real life. You probably have seen one of these. You maybe have one of these. These are three omnidirectional antennas, and we have some interfaces with an Ethernet jack right here. And yeah, this is what a router looks like at a home network. So moving on, what is a hub? So a hub is a layer 1 device that connects multiple computers together. A hub broadcasts data out of all ports because it does not care who receives this data, it will send this data across the entire network segment. A hub interfaces do not create separate collision domains. So let's say you have 4 computers connected to a hub, they will all be on the same collision domain. A hub is a layer 1 device because it's only concerned with transmitting the raw bits of data. And I'll explain further what a hub is with this diagram. So how does this work? So we have 4 computers connected to this hub, okay? And computer A wants to send a message to computer D. If computer A wants to send this message, it will send it to the hub. Then the hub will forward this message to computer D. However, it will also forward this message to computer C and computer B because the hub is not intelligent. You can kind of think as the hub as like a big yapper almost. It just loves talking and it wants everyone to hear him, right? So it will send this message to everyone on the network. And the people who don't want to hear this message will discard it. As you can see in this diagram, computer B and computer C discard this message because that message is not intended for them. This message is intended for computer D, which will accept this message. However, this causes a lot of slowdowns because broadcasts are not good for your network. Let's say you have 50 or 60 broadcasts happening every second or even more. Well, this could congest your network very quickly because, as we discussed before, we can have collisions, and collisions will cause worse network performance. And these collisions can happen because of broadcasts. And this is how a hub looks like in real life. This is a very old image because I currently find much images since hubs are not used a lot anymore in our networks. I do not recommend them to be used ever because they're not secure, since everyone can hear what you're saying on a hub. They provide poor network performance since it runs half duplex, and it treats everything as one big collision domain. So do not use hubs. Really don't recommend it. What is a switch? So a switch is a layer 2 device that connects devices in a local area network. A switch forwards data by using MAC addresses. And a switch has 3 functions: learning, flooding, and forwarding. A switch can segment a network because each interface is its own collision domain. And a switch is much more intelligent than a hub. And I'll explain why with this diagram. So we realized that in our previous network, we had a hub in the middle to connect our 4 computers. But that was starting to make our network slow down a lot. Now we added a switch. And now, as you can see, each interface has its own collision domain. And we also have something called a MAC address table. This is something new. So let me explain what's happening here. So computer A wants to send a message to computer D. So this is the same example that we used in the hub diagram, but now we have a switch. So computer A sends this message to interface 1. Now the switch knows that interface 1 corresponds to the MAC address AAA, which is computer A, right? And the computer A wants to talk to computer D, so the switch will look at its MAC address table and realize, okay, computer D is on interface 2 and its MAC address is DDD, and it will forward this frame to the appropriate destination out of the appropriate interface without interrupting or bothering computer C and computer B, making this process much more secure because not everyone has to listen to what you're sending on this network, and much more efficient because computer C and B don't have to process that message. Now, what is an access point? So an access point provides wireless connectivity. It bridges the wired network to the wireless network. It acts as a wireless hub that allows Wi-Fi devices like smartphone, laptops, or tablets to connect to an existing wired network. An access point takes data from the wired network and sends it out as wireless and vice versa. As you can see here, we have a wired network here: router, switch, and computer C. These are all communicating to the ISP across a wired connection. Now, computer A and computer B, they want to connect by Wi-Fi. Maybe they don't like wires and they just want to connect wirelessly. Well, this is where an access point comes into play. It bridges the wired network to the wireless, allowing for Wi-Fi or wireless connectivity, and this allows computer A and computer B to gain wireless connection without having to use a cable. And this is the beauty of an access point. So here is a picture of an access point, and you would commonly find the find these on a ceiling in something like a school or a corporate environment. And a pro tip, if you ever have a poor Wi-Fi signal, always go closer to an access point. If you find one of these on the ceiling, go underneath it and you should have the best wireless connection across everyone on that network if you're close to it. And if you're wondering, how does an access point, a switch, and router, how do they function in my home network? Well, actually, your internet service provider probably has given you a router that has all those equipment built into that one device. So it has a router, as an access point, and a switch all in that one package. So to sum it up, routers connect disparate networks together. For example, connecting a home network to the internet. Switches are a smarter version of hubs, and they use MAC address to forward frames. Hubs are not intelligent and forward data throughout each of its ports since it runs at layer 1, and access points are used to gain wireless connectivity. And that's my lesson for today, and thank you for watching, and I hope you learned something new.